A good question can be this: you're told that you have two different lines, and the lines are ending up intersecting at a point on your Cartesian plane. You're told to give the point of intersection. So let me give an example. You're told y minus 3 is equal to 2x, and you're given a different line where you're told that 2y plus 3x is equivalent to 8. So this is our first linear equation, and this is our second linear equation. These two different linear equations are represented on a Cartesian plane, and by good luck, these two different equations end up intersecting at a point on that graphical work. So how do you end up getting the region of intersection, the coordinates of the point of intersection? You're first supposed to actually form two different equations, and these equations are supposed to be in the form y, x, and then the constant, or where the line intersects the y-axis. So you can rewrite the first equation. Let me come back to the first equation, and you're actually going to just write it down here. You can say y, then I can take the 2x on this side and be able to take the constant, which is negative 3, to this other side. So I'll have, at the end of the day, y less 2x is equivalent to 3. Why do I even say less 2x? Because the constant here has a negative sign. If it actually crosses the equal sign, it becomes positive. But now the 2x here is able to have what you call a superficial positive sign. On crossing the equal sign, it becomes negative. So negative 3 crosses the equal sign to become positive 3. Then 2x will cross the equal sign with its positive sign to become negative. Now I'll come back to the second equation and look at it. Is it able to get given in such a way that it can have the y and the x on the same side and the constant on the other side of the equal sign? Yes, it is. So I'll just come and drop it down here. I'm going to say 2y plus 3x is equivalent to 8. These are two different simultaneous equations that can get solved using either the graphical method, the elimination method, the substitution method, or you can as well be able to use what you call the matrix method. But now, to better our work in terms of getting the point of intersection of these two different equations, we are going to use what you call substitution method. So I'll come back to my first equation and be able to make one of those letters, either y or x, the subject of the formula. So I'll write that first function or equation down. I'll say y less 2x is equal to 3. I'll take the 2x on this other side, so I'll end up having y is equal to 3 plus 2x. Correct. This is an expression that represents the value of y. I'll come to my next equation that I just have here as 2y plus 3x is equal to 8, and then ensure that where there is y, which is here, I substitute with this expression that got obtained from the first equation. So I'll say 2 into, now there is y here. I don't again write y, and of course the y is this. Its expression is 3 plus 2x. So I'll say 2 into 3 plus 2x, close the brackets. Then I come back here and I say plus 3x. Plus 3x. I must get 8. I'll work out this. I'll open the bracket. I'll have 6 plus 4x plus 3x is equal to 8. To clear my work, I'll say 6 plus 7x is equal to 8. I'll collect like terms. I'll take the 6 on this other side. I'll have 7x is equal to 8 less 6. It is positive. When crossing the equal side, it becomes negative. So I'll have 7x is equal to 2. I will divide both sides by 7. Divide both sides by 7. So the value of x at the point of intersection of these two different linear equations is 2/7. I have to get a corresponding value of y when x is 2/7. I can take any of these two equations. Preferably, I can either take the first equation or take the second equation. any can work for me. I can even take the first one. So I'm going to say y, look at this, less 3 is equivalent to 2x. Where there's x, I'll substitute with 2/7 as my first value that I've gotten from this working. So I'm going to have y less 2 or 3 is equivalent to 2 into 2/7. Why am I putting here 2/7? The value of x that I have initially gotten from this. So I'm going to say y less 3 is equivalent to 4/7. To end my working, I'm going to take this 3 on this other side. I'm going to have y is equivalent to 4/7 plus 3. Okay, so y is equal to, so you're going to say 4/7, then you add this 2, 3. Correct, that must be what I'm supposed to get. So that is 3 and 4/7. So you have y as 3 and 4/7. That is my y value, and that was my x value. So the point of intersection of these two linear equations on a Cartesian plane are going to be the x and the y value. Of course, I have to begin writing down the x value first. I'm going to 7, then I have 2/7, comma 3 and 4/7. Very good. So this is the value of x, and this is the value of y. So the value of x and the value of y can be able to actually get referred to as the point of intersection of these two different linear equations. Thank you, and let's meet in our next video.